Soil analysis is performed to determine the sustainability of a soil for a proposed construction project. The soil beneath the surface is responsible for absorbing the stressor coming from a structure, so understanding how a particular soil will react is critical.
On the other hand, wind analysis is the process of analyzing and assessing the possible wind energy at that specific location. It involves the collecting data of wind speed, direction, and turbulence. It is using the data to predict the possible amount of electricity that a wind turbine could generate at that specific area.
Considering both analysis in building construction projects, it is a must for the engineers to look for an easy way on how to utilize the software programming that will definitely help them analyze the behavior of soil and wind while preparing for building construction.
Presenting our project, which is entitled Optimizing Building Resilience, Integrating Wind Load and Soil Analysis for Enhanced Structural Performance.
Now, we will going to discuss the process on how our program works. So first, after you run the source code, it will introduce to you to the soil and wind analysis, wherein if you click 1 for soil analysis, the program will introduce to you to the 4 types of soil, which is the clay, sand, silt, and loam. Then, if you click the clay, it introduces to you the soil bearing capacity of soil layer and water table depth, wherein the user will input the condition of the soil in this tree. And then after that, after you run that, the program will introduce to you to the overall calculation of the condition of the soil. Then the program will also give you warning if the condition of the soil in the said 3 parameters is too low or too high for the condition of the soil. So it is just the same on how it works on the other 3 types of soil, which is the sand, silt, and loam.
On the other side, when you try to trigger the high warning risk, for example, about high water table, you should try to input like this. First, let's try silt, then 15, then 5, then 1. So, as you can see, there are 2 warnings, but I will read the second warning. So, high water table detected. This may reduce soil stability and bearing capacity. So, as you can see, to trigger the warning about high water table, you should input a water table depth that is less than 2 meters, which is from or based from the condition that we given in the code. If you input a value of 2 meters or greater, the water table will be considered adequate for construction and no warning will be shown at all.
Upon running the program, we will select the option 2 for wind analysis. The user inputs the wind speed, which is 300 meters per second, then the gas factor C for urban areas with buildings and trees. The third is the structure shape, the most common, rectangular, and the fourth input is the exposed area, let's say 100 square meters. The program calculates the wind load and the user specifies the structure type, which is commercial, then office, to assess if the load is within acceptable limits. Warning and recommendations are then displayed if it's not within the acceptable limits. Finally, if satisfied, the user can exit the program by selecting No, then option 3.
Let's walk through how the wind load calculator works. So upon running the program, first, you select wind load calculation. You enter the wind speed, for example 10 meters per second, and then you choose the exposure category like B for suburban terrain and pick the shape of your building like rectangular. After that, you enter the area exposed to wind like 8 square meters. The calculator calculates the wind load, which in this case is 637.52 Newton. Next, you pick the building type like residential and the specific type, say single family house. This will then tell you recommendation wind load is within safe limits for residential structures. And that's it. You can always do another calculation if needed.